And yep, I'm live, and the lighting situation is a bit different because I moved my setup. And yes, here is this is the place that I will be streaming in. You cannot see the new place because not the new place, just a different room because well, you guys are well because I have background. I have what do you call it? I have a background applied. Green screen? No, not a green screen, but my I guess my camera is smart. It can distinguish who is me and who is the background. What is me and what is the background. And we'll just continue, and I will stream for about 1 hour today. And yes, we will continue. Then a video. Stop the music.
Pure functions are almost always a good idea, just like using tabs for indentation. And pure functions have two properties that make them pure. They always return the same values given the same arguments, and they cause no side effects. Let's look at the first point. Here's an example. We have an add function that takes a and b as input and returns the sum. Now, no matter how many times you call add with the same arguments, you'll get the same result. I'll add with 2 and 3 1 trillion times in a loop, and you'll go crazy waiting for anything but 5 as the result. Now let's take a look at a similar but impure example. First, we'll declare a global variable called result and set it equal to 0. Next, we'll define a function called add2result. Now this one only takes one input, we'll call it a. The first thing it does is declare that the result value, or I should say the result variable, is a global variable. In Python, this is required just so that we're allowed to access that global variable from within a function. Next, we'll add a to the result and return that sum. Now, the interesting thing about this function is that every time you call it, even with different inputs, you could potentially get a different result. For example, the call add2result with, say, the number 5, I expect to get back 5 because we're going to add 0 to 5 and return it. But if I call add2result again with the input 5, I won't get 5, and that's what makes it impure. Because the result variable now has 5 in it already, we'll be adding 5 to 5 and we'll get back 10. And this is why pure functions are so convenient to use in the majority of cases. Every time you call them with the same inputs, you expect the same outputs. You don't have to worry about there being hidden random number generators, the state of a database, or whether or not an internet connection is available in order for the function to work as expected. And because they're predictable, they're easy to test and debug. You can write an entire suite of unit tests for a pure function, and assuming they pass, you can expect, not just expect, but they will work the same way in production given the same inputs. If you've ever experienced the "well, it works on my machine" meme, that's not a problem with pure functions. Impure functions are the ones that made that meme popular. So if pure functions are so great, then why don't we just make all functions pure? Well, by definition, pure functions can't have side effects. And a program that has no side effects is effectively useless. It just makes your computer heat up, but to no result. If your program has no side effects, it can't even print to the console. It can't access the internet. It can't update a database. It can't even draw buttons on a screen. So what should you do? Well, my rule of thumb is I try to make as many of my functions that can reasonably be pure, I try to keep them pure. And I try to keep the number of side effects in my code contained to just a few places, usually somewhere near the top level of my code. That way, when other developers are working with my code, it's obvious where the side effects are, and everything else is fairly easy to test and debug.
Okay, pure functions. If you take anything else away from this course, please take this picture. Pure functions are fantastic. They have two properties. They always return the same value given the same arguments, and second, they have no side effects. Example of a pure function assignment. There's a bug in the convert file format function right now. It relies on data outside its own scope. These global values can be changed by other parts of the code, so they are not guaranteed to be the same every time convert file format is called. Yes, fix the bug by making convert file format. convert file format. I have to make this independent to valid conversions, valid extensions. It takes in a file name and a target format. And what does it do? Current format equals file name dot split on a dot get the last thing. Okay, and that gives me the file format. And if file format invalid extensions and target format invalid conversions, this then to this return file name dot replace current format with target format. Okay, to make this work, I can do copy these two, paste them there, intend them, and that I guess should work. Run. That does work, and that does work. It should only depend on data that is scoped inside of the function. Yep. So put the data inside the function. And now pure functions review. Example one, two. Example one is okay. Takes a number. It has an array. For nums in number, the append a new product by multiplying it by 2 and then return products. That is impure. Shit, my bad. It makes changes to products which is there already. Yeah, my bad. It is pure. That was stupid. Example 2 is it has two variables outside of its scope and it is making changes to them. So it is impure. I still feel bad about getting this one wrong. Example 3, import random roll die num side random, return a random number from 1 to that. That is impure. Yes, because by definition it does not give you the same output for every same input. Reference versus value. Yes, reference. Sometimes you send a reference and sometimes you send the value, a copy of the value. When you pass a value into a function as an argument, one of the two things can happen. It is passed by reference. The function has access to the original value and can change it. It has access to the original value and can change it. It is passed by value. The function only has access to a copy. Changes to the copy within the functions don't affect the original. There is a bit more nuance, but this explanation mostly works. These types are references, lists, dictionaries, and sets are references. These are not copied. These are sent as by reference, the original address or pointer, you would say. You could say integers, floats, strings, boolean, tuples are sent by values. Even tuples are sent by values. Okay, and all of these things are immutable, and these are mutable. That might tell you something about them. Most collection types are passed by reference except for tuples. And most primitive types are passed by values. Example of pass by reference, mutable. Lists, inner list dot append 4, right? It takes in a list and appends 4. Outer list is this, called the inner list function, print. Yep, 4 is added. Now example pass by value, it takes in number, outer number adds 1. This adds 1 to the number, but since the number is passed by value, nothing is changed in outer number. Assignment, we have a way for doc-to-doc users to send their supported formats in their settings. In memory, we store those settings as a simple dictionary. Okay, unfortunately, there is a bug in our code. When a new format is added or removed, when a new format is added or removed, it not only updates the new dictionary, but it changes the defaults themselves. It not only updates the new dictionary, but it changes the defaults themselves. That is not good. We want to create new dictionary with the updated change, not the original. Unfortunately, there is a bug in our code. When a new format is added or removed, it is not only updated. It not only updates the new dictionary, but It changes the defaults themselves. It is not good. We want to create a new dictionary with the updates, not change the original. Fix the bug by making add format and remove format. Pure functions that don't mutate their input. Add format and remove format. Okay, and this is the default format, and then I have a new format. Okay, so return and return dictionary equals something, and for key in default formats, I can do return dictionary bracket key equal default format bracket key, and then at the end return dictionary bracket a new format equals true. But there is something. I can just make this true, simply true, and yep, return return dictionary. Do the same thing below, right? Return dictionary default formats, copy the formats, and then yep, a new for remove format. Okay, remove format can do instead of this, remove this, delete, right, and return dictionary. That should work, I guess. New format. Yes, new format does not exist. Only old format does, and two fails, one passes. Why? Input was this false. Okay, I have not deleted, but I have to make it equal to false. Equals false, and then run. That is still fails. Old format, default format, remove format. It takes in an old format, and this one takes in a new format and makes it this. That should have worked. I actually got this. Expecting MD false, text also false. Text was originally false, but it passed in MD, and MD should have been false. Yes, in this case, MD should have been false. Return dictionary, old format equals false. It should have been false. Well, yes, okay. My bad, my bad. Uh, Default formats, bracket key. A setting can be true or false, and that depends on what the default is. Yep, now it works. Now next, pass by reference impurity. Because certain types in Python are passed by reference, we can mutate values that we didn't intend to. This is a form of function impurity. Yeah, because values are passed by reference, some values are passed by reference, we can change them and cause a side effect. Remember, a pure function should have no side effects. It shouldn't modify anything outside of its scope, including its inputs. It should return new copies of inputs instead of changing them. Pure function, remove format, takes in format, and okay, there is a copy function. Okay, I can use that. And impure function updates the old one. Why do we care? One of the biggest differences between good and great developers is how often they incorporate pure functions into their code. Pure functions are easier to read, easier to reason about, easier to treat, and easier to combine. Even if you are working in an imperative language like Python, you can and should write pure functions whenever reasonable. There is nothing worse than trying to debug a problem where the order functions are called needs to be just right because they all read and modify the same global variables. Yep. A pure function not mutate its local can mutate its local variables, mutate its input, nope, mutate global variables, nope. Call functions that mutate globe first, mutate its local variables. Now, pass by reference impurity. Pure functions should be avoided at execute fast now are easier to debug, read, and test. The next input and output. Should that is why. Yep. XKCD. XKCD is a man, of course. I am glad you are including more comments in your code, but if it would be nice if there were comments about your code, or at least a bit less obscene obscenity filled. Look on they say to write what you know. Okay, I'm glad you are including more comments in your code, but it would be nice if there were comments about your code, or at least a bit less obscenity filled. Obscenity, meaning obscenity. Sexual words or acts that shook people or and cause offenses. That is obscene. Shit, yes, obscene. I've heard it. Sexual language or behavior, especially in books, plays obscene. Obscene. Okay. Obscenity filled. Look, they say to write what you know. That is what she knows. All the functions you have written take everything passed to them and return it unchanged, while the comments, no, you deal with this, uh, and return it unchanged. With the comment, no, you deal with this. It is a functional programming thing, avoiding side effects. You avoid all side effects. Only way to be sure. That makes sense. That makes a little bit sense. Avoiding all side effects. If there are side effects that can be managed by a function better and not give that tension to the main function, then you should call side effects. The term I/O stands for input output. In the context of writing programs, I/O refers to anything in our code that interacts with the outside world. Outside world just means anything not that's not stored in our application's memory like variables. That is not stored in our application's memory like variables. Outside is world. Okay. Examples of I/O: reading from or writing to a file on the hard drive. Okay, even hard drive is the outside world because inside is just the memory, the RAM, access to the internet, reading from or writing to a database, even simply printing to the console is considered I/O. Okay, all I/O is a form of side effects. In doc, we frequently need to change the casing of some format. For example, title case. This is the title case. This is lower case and uppercase. There is an issue in the convert case function. Our test suite cannot test its behavior because it is printing to the console. How a side effect. Instead of returning a value, fix the function so that it returns the correct value instead of printing it. That should be easy enough. Instead of doing print, I can just do return and do the same here and return do the same here and run, and that does work. Yep. Moving on. Should I input output? A program that doesn't do any I/O is pretty useless. What is the point of computing something if you can't see the result? Shit. I am a functional programmer. What does that mean? It means he is scared of side effects. I am not. Ooh, print. Stop it, you are scaring him. Okay, in functional programming, I/O is viewed as dirty, but necessary. We know we can't eliminate I/O from our code, so we just contain it as much as possible. There should be a clear place in your project that does nasty I/O stuff, and the rest of your code can be pure. For example, a Python program might first read a file from the hard drive as the program starts. Read file from the hard drive as program starts. Run a bunch of pure functions to analyze the data. Write the result the analyze of the analysis to a file on the hard drive at the end. That is cool. Yep. I/O should be dash in functional programming contained std only used when Simpson Peyton Jones isn't looking. I do not know who that is. Limited to specific parts of the code base. Yep. Simpson Pates Jones. Simpson Peyton shit. Simpson Simson Peyton and PY Jones. Okay, British computer scientist. I do not know him. The core and has followed Simpson Peyton John. A British computer scientist who researches the implementation and application of functional programming languages, particularly lazy functional programming languages. Lazy functional programming. What is the meaning of that? Lazy evaluation. What is that in programming languages? In programming language theory. That is lazy programming language theory. PLT, lazy evaluation, or call by need. A function is only called when needed. Yes, that is what it does. Is an evaluation is strategy, not a tactic. A strategy which delays the evaluation of an expression until its value is needed. Okay, so if I say, so it does mean something like this. Like if I were to say, let int a equals 2 plus 3 and like int a equals this, and then I do a bunch of stuff, and then at the end at some point I do printf a. Only then is the value of a calculated when I am actually using it. Okay, if that is what it means, I guess that is what it means, right? Simpson Peyton Jones, that is the correct pronunciation that I'm going with. And from the user's perspective, a program with no I/O does nothing. Can only read from an external database, can only print to the console. Nope, it cannot do anything. It does not do anything. No OP, object programming operation is an operation that does nothing. No OP. Okay, like like uh, a single semicolon in C. If a function doesn't return anything, it is probably impure. If it doesn't return anything, the only reason for it to exist is to perform a side effect. Example, no OP. This function performs a useless computation because it doesn't return anything or perform a side effect. It is in no OP. This function performs a useless computation because it doesn't return anything or perform a side effect. Okay, example, side effect. This function performs a side effect. It changes the value of y variable that is outside of its scope. That is outside of its scope. Yes, that is correct. The global keyword just tells Python to allow access to the outer scoped y variable print. Even the print function technically has an impure side effect. It doesn't return anything, but it does print text to the console, which is a form of input output. Yes, complete the remove emphasis. Remove emphasis from line, remove emphasis from word functions. They are currently no ops because they do not return anything. Remove emphasis is the parent function. It takes a full document with any number of lines and it removes a single line. It takes a full document of any number of lines and and removes any single or double star characters that are at the start or end of a word, that are at the start or end of a word, like this. It removes this and this. Okay, write the helper functions. They will make the remove emphasis function much more easier to write. Okay, helper functions. Yep. The remove emphasis from word function should remove emphasis from a single word. The remove emphasis from line should split a given line into words and use the function we just created to remove emphasis from each line. Okay, remove emphasis function. It takes in doc content and it. Right. Don't forget to handle new line character appropriately at the end of each line. Yep. Let's say it. What does it do? It splits the docs and sends, okay, for I into for I in doc content dot split this at new line and everywhere with every line call the remove function and store those new lines in a new variable, in a new array, right? Uh, a final array, no. Mm, corrected array, corrected array equals empty, and here corrected array dot, not push but append, corrected array dot append remove emphasis from line for I, or line is a better word, line, and yep. After that, just join the lines on a new line character, right? Uh, corrected dot equals new line character dot join join the corrected array and return that, or don't even do that, just return that. Remove emphasis for line. Okay, right, corrected words empty array for word in line dot split the line at spaces, and then do corrected words dot append remove emphasis from word for the current word, and then after that return by joining them at a space, join corrected words, right? And in this I have a word, I have to fix that. For I have to see, like, there could be 2 stars in the front. Yes, I have a word. There could be 1 star at the start and 1 at the end, or 2 stars in the start. So I know, if word 0 equals dash with this, and yep, I see that. And if word, this is very specific, but this is how I want it to be, because there could be stars in the middle of the word, so I do not want to change them. If word 1, if word 1 equals star, then I have a different procedure, and else a different one. If word 1 is also star, then return word starting from 1, 2 till the end, and otherwise return word starting from 0, 1 till -1, and Otherwise, if none of that is true, then just return the word. That should work. That does not. Join array. Okay, yep, remove that and run. And okay, word 0, string index out of range. Okay, string index is out of range for this thing due to some reason. Print word, not printf, print. Okay. Input.document this, don't panic. What do I get expected? Print, look here. Let's see, look here. This is one word, and look here, this is another word, and then look here, and the word is empty. Why is it empty? Corrected words, line dot split. Okay. Splitted line equals line dot split and spaces, and here pass in the splitted line. Do the same here. Splitted doc equals doc content dot split at new lines, and fuck, here you yep, do this in split lines, and also print splitted lines, and before that print splitted lines here. I am seeing that I am not speaking as much as I used to, but that is fine. Yes, this is correct. This is correct. I don't see any problem. Yep, that is a problem. That is a problem. Copy this thing, paste, split lines. Nope, this is not. This is split it. Doc, print the document itself. Let's see. Splitted lines are here. Split lines are here, and remove that. Where is splitted doc? Oh, this is a splitted doc. My bad. Splitted, not line. Doc. We'll see it. Splitted doc here. Okay, last one is just empty. Okay. If I'm splitting lines, if the last one is it ends at new line, if that makes sense. Okay, that makes sense. So I can do this from starting except the last character, and at the end join them by this and plus a new line character. That should work. Two phase, okay, but that is fine. We can do this. This one passed. This one, I suppose, failed due to some reason. Yep, this failed. Actual answer, the answer to the ultimate question. There are two of these here. And what did it expect? Expected output. The answer to the ultimate question. The answer to the ultimate question to is this. Okay, there can be two of these at the end. Okay, flow document with any number of lines and remove any single or double star characters that are at the start or end of a word. Yes, in this case, they are at the end of a word. So, yep. If there is a star at the start, then do this. And wait, there can be a single. Can there be a single star just at the start or just at the end of a word? Removes any single or double character that are at the start or at the end of the word. Oh, yes. Okay, I will see if there is a star at the start, and then I'll see if there is a star at the end. And okay, I have to check a few things. First, if there is a star at the start. If there is, remove that and see if there are two actually, not just one. So word equals word this, right? And yep, no else, not right now. And then yep, if word bracket -1 equal to star, that is the last character is a star, then I would like to check if the second last is also a star. If word -2 is also a star, I think I have seen a problem in my last one. Then take it from the start till is I want to skip the last two characters. Say that is this correct, and in this else there also has to be an else statement where word equals word starting from the first word. And in here else word equals word. It does not have it does not it can contain it only has to skip the last one letter and then return the word. That I guess could work. And does it? Yep, it does. It does work. That is correct. Again, remove the comments then now. But there are still fucking comments. Yep, there are. And now that is fine. And one fail. Okay, what is that? One fail. One fail. One fail. One fail. Everything passed except one. This one. When the document is empty. Well, if length of doc content equal 0, return empty. That should work. Yes, that does work. Shit, my level increased. I am equalite now. Memorization. At its core, memorization is just memorization, not like human memorization for programs. At core, memorization is just caching, storing a copy of the result of a computer so that we do not have to compute it again in the future. For example, take this simple function, this thing, a call to add 57 will always evaluate to 12. So if you think about it once, we know that add this can be replaced with 12. We can just store the value 12 somewhere in memory so that we don't have to do the addition operation again in the future. Then if we need to add this and this, again we can just look up the value 12 instead of doing a potentially expensive CPU operation. The slower and more complex the function, the more memorization can help speed things up. It is pronounced memorization, not memorization. Memorization. Memoization. Memoization, not memorization. You shit, it is memoization, not memorization. Memoization. This confused me for quite a while in college. I thought my professor just didn't speak goodly. Memoization. Okay, it is called memoization. Assignment. Counting the words in a document can be slow, so we want to memoize it. Complete the word count memo function. It takes two inputs, a document and memos dictionary. The keys are full document strings. The keys are full document strings, and the values are the word count of the document. It should return two values, updated memo dictionary and the word count of the given document. Here are the steps to follow. Create a copy of the memos dictionary. Yes, I do not want to change the original one. Create a copy. If the documents is in the memo dictionary, just return the associated word count and the memos copy. No need to recompute the word count, right? Otherwise, use them provided word count function to count the words in the given document. Don't edit anything below this. Memo copy equals memos dot copy, and if a document in memo copy, then return it has to return two things. So return a tuple, return the word count and the updated memo copy in the same order, I suppose. First is memo copy word count, and the second is the memo copy, right? And else if it is not there, then return word count for document along with memo copies. I have to add that to memo copies. So count equals word count for document, and here a return count along with memo copy bracket document equals count return memo copy. That should be it. That is it. Submit. Yep, that is cool. And referential transparency. Let's see.
Referential transparency. Pure
Transparency.
functions are always referentially transparent. Referential transparency is a fancy way of saying that a function call can be replaced by its would-be return value because it's the same every time.
That makes sense. And yep, the stream is fine. Yep. But I stopped the music. I should not have. Yeah. No. Referential transparency is a fancy way of saying that a function can be replaced by its would-be return value because it is the same every time. Referentially transparent functions can be safely memoized. For example, add 2 plus 2 and 3 can be smartly replaced with the value 5. The great thing about pure functions is that they can always be safely memoized. Impure functions can't be because they might do something in addition to returning a static value, or they might return different values given the same argument. Yep. Should I always memorize? It depends what is the frequency of you calling the same function with the same values, and also on the computational cost of calling each iteration. No, memorization is a trade-off between memory. Yes, because you will be using memory. If your function is fast to execute, it is not probably not worth memoizing because the amount of RAM, memory, or program will need to store the result will go way up. It is also a bunch of extra code to write, so you should only do it if you have a good reason to. Which expression is not referentially transparent as the integer 5? This this thing will return 23, like 23 as a string. Now the last lesson in this chapter. Okay, memorization trades off dash for better dash. Memory for better speed. Memory usage for speed. Yep, and then optional, I am just going to skip sort data, sort dates. Yes, I am going to skip the option keyword searching. So yeah. Moving on to recursion. And now I cannot submit the answers. That is fine. I'm just going to stream for 1 hour and it has been 45 minutes, 15 more minutes, and then I'll do my stuff, like work on my own. Recursion is a famously tricky concept, and I will be working on my own because shit, this is 8 minutes long. That is like half of the remaining time that I have to stream for. Now, like after doing about 85 streams, I have realized that it is much faster if I'm not streaming and just programming on my own because I do not have to speak this much and I do not have to explain things to others and at the same time being able to understand those things on my own. So it is much faster if I'm not streaming. And let's watch the video.
Recursion is a word used to strike fear into the hearts of new programmers. It's a simple concept that just takes a second to learn how to use properly. Recursion is just when a function calls itself.
Mm. The meaning.
Recursion is just when a
Learn to program make recursive functions. No exit condition. Learn to program. Shit.
function calls.
That is funny. I guess that is funny. That is how I get all my memes, either from this or from Fireship.io.
Itself. Now, that might sound fairly straightforward, and it is, but it is one of the hardest concepts for new developers to learn. So don't beat yourself up if it takes just a little extra practice and a few more examples before you fully understand what's going on. Let's take a look at this simple example. We've got a function called countdown, and it takes as input n, an integer. First, it just prints n. After it prints n, it calls itself again, but only after subtracting 1 from n. So what happens if we call countdown and pass in 5 as n? Well, first, 5 is printed to the console. Then countdown is called again, but this time with n minus 1, or 5 minus 1, which is 4. So we go back to the top of the function. Now we'll print n, which is 4, call countdown again, this time with 3, and on forever. So we've figured
Forever.
out the recursive part, but the problem is this function will never stop. I can't stop. It will keep calling countdown over and over and over, decrementing by 1 every time, even into the negatives. Countdown with -1, -2, -3. So what we need is a base case to stop the recursive madness. Let's add an if statement to the top of the countdown function. If n is less than or equal to 0, instead of printing n and recursing again with n minus 1, we'll just print the word blast off to the console and return immediately, again stopping the recursion. So what happens now if we call countdown with n of 5? First, 5 is printed, then we call countdown again, and that's because 5 is greater than 0, so we're not going to trigger that base case. Next, countdown is called with an n of 4. Again, we're skipping the base case because n is greater than 0, 4 is printed to the console. This continues all the way down until n is less than or equal to 0. So when n is 0, we'll enter that if statement, print blast off, and then return. And because we're returning, there will be no more recursive calls to the countdown function. So the final result is that when we call countdown of 5, 5, 4, 3, 2, 1, blast off is printed to the console. Now let's take a look at one more example. Let's say we want to write a function called dictDepth that returns the depth of an arbitrarily nested dictionary. For example, this dictionary only has a depth of 1. It has 2 key value pairs, but there's no nested dictionaries within it. But if you take a look at this dictionary, it has 3 nested levels. Melee weapons corresponds to a second dictionary, which has the key stabbies, which corresponds to another nested dictionary, a total of 3 levels. Now, because the dictionary passed into our function can be arbitrarily deep, recursion is a really good fit for this problem. So let's figure out what our function signature should be. We'll define the new function, we'll call it dictDepth, and we'll pass in 2 parameters, d, the dictionary itself, and then max depth so far, which is just going to keep track of how far into the nested dictionary we are at each level of recursion. Now this time let's start with the base case, just so we have a different way of approaching this problem. And our base case should be when there's no more dictionaries to recurse into. So if d is not a valid dictionary, for example, if it's
Is not instance. If not is instance D of dict or not D. Okay, what I get if that thing is not a dictionary or if it does not even exist,
just a number,
then
like the
okay.
number that corresponds with the Bose key, 6, then we're going to stop recursing. So we'll just add this if statement that says if d is not a valid dictionary, immediately return the max depth so far. Okay, now we need a recursive case. We need to figure out how to go from the top level dictionary to the next level nested dictionary, or dictionaries, because there can be multiple key value pairs. So first, we'll set a current max variable equal to the max depth so far. And the purpose of this variable will be to keep track of the max depth of all the nested dictionaries at this level. Next, we need to iterate over each potential dictionary at this level. In Python, there's a .values method that we can call on a dictionary object to get every value in that level of the dictionary. Now, at each key value pair, we'll recursively call dictDepth, but this time we'll only pass in that nested dictionary. So instead of passing in D, we're going to pass in V. We also need to increment the max depth so far by 1 because we're going 1 level deeper. Now, once that recursive call returns, it will return with the maximum depth of that sub-dictionary.
Depth of subdictionary equals depth of dictionaries. But I want to get the maximum depth. I am just overriding it. Why am I catching this value? Depth of subdictionary. Depth of subdictionary. Why am I catching this value? Return current max. Yep.
So we should track that max depth, and at the end of the loop, if that max depth is the greatest of all the nested sub-dictionaries, that will be the one we'll return. So with the first call to dict depth, we're going to pass in a dictionary, D. It has 3 layers. The first level has melee weapons as a key, which corresponds to a single dictionary. It's the only key at the top level. The second level has 2 keys, stabbies, which corresponds to a third dictionary, and bows, which just corresponds to number 6. Going down into that deepest level, we've got a dictionary with 2 keys again, spears and knives. Spears mapping to 4 and knives mapping to 3. We also pass in a max depth so far of 0, just because this is the first call. So what happens? Well, first, in this initial call to dict depth, the base case is going to be skipped because we pass it a valid dictionary. Next, we'll set the current max to the max depth so far, which is 0. And that will be overridden within our loop if we find a recursive call that returns a greater number. Now we iterate over all the key value pairs in the dictionary, which in this case is just the melee weapons key. We enter the recursive call, where we pass in the dictionary that corresponds with the melee weapons key, that sub-dictionary. We also increment the max depth so far to 1. Within that recursive call, again, D is a valid dictionary, we'll set the current max to 1, which is what the max depth so far was. Then we'll iterate over each key value pair again. This time there are 2. The stabbies key and the bows key. Because the stabbies key is first, we'll start there. We'll kick off another recursive call, this time passing in the dictionary associated with the stabbies key. We'll also increment the max depth so far to 2. We'll iterate over each key value pair. Again, there are 2. Spears, 4, and knives, 3. Starting with the spears key, we move into another recursive call. This time, the value 4 is not a valid dictionary, so we trigger the base case and immediately return 3, which was the max depth so far that we passed in after incrementing it. Now we're back up a level after returning 3. We move on to the next key in the dictionary, the knives key. Again, it kicks off a recursive call. The max depth so far, again, is 3, because we've incremented it from its parent function, where it was 2. Again, D is not a valid dictionary, so we'll immediately return 3. Now, back up again in that parent function, we've iterated over both key value pairs, and we're going to return the maximum of the 2 return values, which because they were both 3 is just 3. So that will return up the call stack again. Now we're back into the second call. There's another key for us to process, the bows key. That will kick off a recursive call. This time, D, again, is not a valid dictionary. It's just the value 6. So we'll return 2, because 2, again, is incremented from this call's parent function where it was 1. Now we've iterated over each key in the dictionary, the stabbies key and the bows key. The recursive call to the stabbies key returned to 3, while the recursive call to the bows key returned to 2. So this call, which will return the maximum of the 2, will return a 3. Now we're back in the original function. We've iterated over all the keys, which in this case was just the melee weapons key and its associated dictionary, and we'll return 3, and the recursion is done.
Yes, that makes sense. Now, example of recursion, which is just, what does it do? Some numbers, if the current array has the size 0, then just return 0. Otherwise, add the first number to the sum starting from the second element. Right, okay, that is cool. Solve a small problem. Don't break your brain on the example above. Let's break it down step by step. Solve a small problem. Yep, recursion, and that is assignment. Doc to doc can automatically generate various layers of a page. Okay, there are a lot of possible layouts, so we need a factorial function to calculate the total number of possible layouts. Factorial is this, right? The factorial function. That is the function that I wrote first. Shit, I am in guest mode. I want to write factorial function, so I will write factorial function. cd python lsn. I've already written factorial function. Factorial.py. I will just write another one. Yep, I have already written it. I'll write it anyway. Let's make it def factorial. It will take in x, and then I'll do if x is equal 1, then return 1, right? And else return x multiplied by factorial bracket x minus 1. And then I'll do print factorial of integer of input of enter a number. Right, let's see. Python 3 factorial.py, enter a number 5. Factorial is 105, and enter a number, let's say 7 factorial is 5040, and about 6 more minutes, and of course the music. Tame Impala? Nope. Where is the music? Sure. Let me play Oppenheimer for the last bit.
Sheet music, the important thing isn't can you read music, it's can you hear it? Can you hear the music, Robert? Yes, I can.
It is just one of the best soundtracks there is. Now moving on. After the factorial, what do I have? Your party enters the tavern. Okay, and this person says, then I gather everyone around a table. I have the elves start whittling dice and get out some parchment parchment for character sheets. Hey, no recursion. Your party enters the tavern. Okay, and this one says, I gather everyone around a table. I have the elves start whittling dice and get out some parchments for character sheets. And I hate explaining jokes, but in case you don't get the comic, the joke is that the characters within the Dungeons and Dragons games wait, it, it is getting a bit too loud for me. I hate explaining jokes, but in this case, the joke is that the characters shit, yes, decrease the volume for myself, not for you. Yeah, that is fine. Uh, yeah. And the joke is that the characters within the Dungeons and Dragons games are also playing their own Dungeons and Dragons games. Maybe their characters game of Dragons and Dungeons also has characters playing Dragons and Dungeons and so on. Right. Hello world. If I have a word and if I equals length of the word, then just return. Otherwise, print the ith character and print the next character. Shit. That is also recursion. What happens if a recursive function has no base case? It will just keep on recursing. It is no longer considered as recursive. It is recursive. It will keep calling itself forever, resulting in an infinite loop. If that is correct, Alan Turing comes back from the dead to haunt the author. Yeah, second one is true. But what is printed if I call print chars? If I called print chars element 3, ELEPHANT. Okay, starting from 3 in 0, 1, 2, 3. PHANT. PHANT first one is the correct answer. Then Zigmap. Let's practice another simple recursive function. You may not understand recursion yet. I do a bit, but by following the instructions, you will begin to grasp the fundamentals assignment. Within doc to doc, we need to map certain properties uh, from one document to properties of another document. Complete the recursive zig map function. It takes two lists as inputs and returns a dictionary where the first lists returns a dictionary where the first list is the key and the second list provide the values. And I have to write that as a recursive function. That is cool. I can just slice, add one key value pair, and then slice the dictionary and then call it recursively on that same dictionary. On that same dictionary. What will the function return? The function will return a dictionary. Should it? Yes, it should return a dictionary. And after adding a key value pair, it will call itself and add something more to that dictionary. But how would I translate that dictionary into? I can create a copy of that dictionary and add my current key value pair to that copy. That makes sense. And since I cannot write the code, I'll just move on. Recursion quiz. Consider the following function. Print n, right? If n equals 0, return. If it is not, then count down n minus 1. Which line has the base case? This line. If n equals 0. Second one. And which line contains the recursive call? Last one, countdown. Yep, last one. What would happen if we swapped countdown n minus 1 with countdown n for n? It will infinitely call itself. It will become an infinite recursive loop. The last one is the correct answer. Nested sum. Recursion is hard for all new developers. If you are struggling, that is okay. Take your time. That is why we are doing a few extra practice problems. I got this. I suppose I can do this, right? And yeah, I can probably do this. It takes all the fun away when first I already know recursion, not to the best degree that I can know, but I know more than what I'm getting from this. And second, I cannot submit the problem, so just hypothesizing about it is does not feel too good. Recursion is so dang useful with tree-like structures because we do not always know how deep they are nested. Stop and think about how you would write nested loops to traverse a tree of arbitrary depth. It is not easy, is it? Yep, it is not. And most often, it cannot we use a while loop. Maybe in some case we can use. Nah, I guess yeah, we can figure out some way to use a while loop instead of recursion or BDS or and DFS or BFS could also be used there without recursion by keeping by using queue or stack in some priority way, heap or something. I most often use recursion on tree-like problems like file system nested dictionaries, etc. If I am just iterating over one-dimensional list like a loop, then a loop, gasp. It is typically simpler, even if it is not pure in academic sense. Remember, the rules of functional programming are just philosophies to help you write better code, but it is not always the right tool for the job. The same goes for any programming paradigm. Okay, what makes it hard to loop over a tree? Because would you do it? You don't know the depth of the tree. Yep. You don't know the breadth of the tree, number of items at each level. That does not cause any problem. The tree has too many elements in the initial list. No. Loops are hard for my smooth brain. Nope. First one is the correct answer here. Imperative loops are always allowed in purely functional programming. Imperative loops are always allowed in yeah. Imperative loops or imperative. Well, they are not like impossible to apply. They are allowed but not used. Uh, and this is true. Imperatives, programming constructs such as this and this that allow to repeat block of code. Yep, they are allowed. There is nothing against them. Loops are used often by good programmers, even though they break the academic rules for functional programming. Yes, 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 yes. They are often used in good cases when they are like a better choice. Recursion on a tree. Recursion is often used in tree-like structures. For example, nested trees, file systems, file systems. I will be using recursion on file systems when doing something big. HTML documents, JSON objects. Yes, that is because trees can have unknown depth. It is hard to write a series of loops because you don't know how many levels deep the tree goes. Yep. And then the assignment, which I can probably do looking at this. Yes. For the current key, take the key as a string and append to it by whatever you get after calling the function on this thing. And if the answer is if the thing that I get at some point is none, then return empty string. Return nothing, empty string. Danger of recursion. Recursion is great because it is simple and elegant, but often being the most straightforward way to solve a problem. But there are some things to watch out for. Stack overflow. Each function call requires a bit of memory. So if you recurse too deeply, you can run out of stack memory, which will crash your program. This is what famous website is named after. Stack overflow. A stack contains the context for the current function in which the current function is being called, and if you are calling a lot of functions, then different contexts will be stacked on top of each other, and that space in memory can be filled. If you don't have a solid base case, you can end up in an infinite loop, which will likely lead to stack overflow. Recursion, especially in a language like Python, is often slower than for loop because each functional call requires some memory. Tail call optimization can help with this, but Python doesn't support it. I do not know what is tail call optimization, but we'll see. And I guess my stream is lagging. Probably it is lagging, and you guys, I guess, are not able to see, or maybe you can hear, but not clearly. Which is typically more performant in Python, a regular loop or a deeply recursive function? A regular loop is better. And thus we have completed this recursion chapter, and we can move to function transformation. Function transformation. And that is the end of this stream. Bye. No, with the music.